Hi everyone, I'm Paula from OneCodeCamp. Welcome back to our channel. Today we're going to take a look at how to send and record messages over the Ethereum blockchain. Let's take a look at this transaction that was sent over the Sepolia testnet on Ethereum. You can see over here the address that the message was sent from and the address that it was sent to. You can see also that I sent a value of 0 Ethereum and I only paid a transaction fee or a gas fee. We also see the unique transaction hash that was created when the transaction was successfully sent. If we scroll down a bit, we can see over here the input data. Information on the blockchain is not stored directly as text, but as hexadecimal characters. We will see this in a little while when we use a message converter to turn string into hexadecimal and also to convert it back into readable text. But in this case, you can actually already read the data within the block transaction. It's just not plainly visible. We will have to click View Input As, UTF, and there we can see that the message was actually Hello World. Let's take a look at the steps we actually took to send this message as a blockchain transaction. First things first, we're going to need a MetaMask wallet. First things first, we're going to need a digital wallet. In this case, I am using MetaMask, which is a popular choice for interacting with the Ethereum blockchain. I'm also connected on the Sepolia test network. And in order to send transactions, I used Sepolia ETH, which are test tokens. Since this is for demonstration purposes only, I won't be using any real currency. Although, as you saw from the earlier transaction block, I actually did not send any real value except to pay for some gas fees. So a little bit of test Sepolia ETH will do. You can get those from using the Sepolia faucet. Back to our MetaMask. Now, in order to send a transaction, we're going to need first some test tokens or some currency, and we're going to need an address to send the transaction to. And we're going to click on the send button over here. And for me, I'm going to transfer to my second account right here. This is the amount that we want to send. It can be 0. And in here is the hex data, which is where we will input the message that we want to send as hexadecimal characters. Now, in order to see this hex data field, you do need to head over to your MetaMask settings and make sure the hex data setting is on. Now, I'm going to use a string to hex converter to get the hexadecimal characters for the message I want to send. Here's a look at the message that I sent in the earlier example, Hello World. Let's try a different message this time. I'm going to say, Hello YouTube, I'm sending this over the blockchain. And you can see the encoded string updating in real time. So I'm going to copy this full string and I'm going to head back to my MetaMask and I'm going to paste it right here. You can also see the gas fees updated in real time based on the data that I'm sending. Now, as mentioned earlier, we can leave this at 0 and we will only need to pay for the gas fee. So I'm going to click next, confirm my transaction, and wait for it to successfully send. There we go. As you can see, the transaction has successfully completed, and we can now click on this to view it on the Block Explorer. There we go. So we have a brand new transaction hash. We can once again see the from address and the to address and the exact transaction fee or gas price paid for this specific transaction. If we scroll down once again, we can see the input data and we can convert this into something readable. There we go. Hello YouTube, I'm sending this over the blockchain. So as you can see, this is how we can send messages as data over the blockchain, where it can be stored permanently and immutably. While the message is visible on the Block Explorer, it's hidden from plain view. Anyone who wants to see the message would have to seek it out specifically by knowing the transaction hash or by knowing the exact from address or to address. Now, what if we didn't want to take all of these steps each and every time we wanted to send a message to somebody? What if we wanted to create a specific interface where we can just type the message in human readable language and go ahead and send it without having to manually convert it ourselves? But we're going to do that in another video. Thank you so much for watching, and we will see you in the next one. Now, in this video, we are going to create a Solidity smart contract for sending and receiving human-readable messages over the blockchain. Each message sent will be considered a transaction on the blockchain and stored there permanently and immutably. Only the receiver address will be able to view the messages that were sent to their wallet address. Now, since this is for educational purposes only, you may notice that we will be missing a few key features, such as the ability to group and sort conversations between two wallet addresses. This means that all messages will be grouped together based on whether there is an incoming message or an outgoing message. We also will not be going over message encryption, as this topic will be a little too advanced for now. Now, to get started on this project, I've opened up my Visual Studio Code to a directory I've named Messaging Demo. Now, in here, I'm going to open up my terminal. I'm going to make a directory called Hardhat, and within Hardhat, I am going to initialize and install Hardhat. Now, this might take a minute or two, so we will return once it is completed. If you want to know more about Hardhat, read their tutorials or their documentation, you can head over to their official website, hardhat.org. Now, once it's done installing, we will run npx hardhat to execute our Hardhat. We are going to create a JavaScript project for here. We're going to use the suggested project root, add a git ignore yes, and we're also going to install the recommended plugin, Nomic Foundations Hardhat-Toolbox. And once again, we're going to come back when this is done. Once that's done, let's close our terminal for now, and we can take a look at the files and folders that it created for us. We have a scripts folder, which we will be using later on to deploy our contract, and we have the contracts folder with a test folder called lock, that's all, which I will be deleting as we won't be needing that. We will then create our own contract in the contracts folder, which I am going to name chatting the app.sol, which stands for Solidity. Now, we start every Solidity smart contract by first declaring the license and the version of Solidity that we will be using. So I'm going to type pragma, press tab to enter the snippet. I'm going to be using version 0.8.0 up until the latest version. And for the license, I'm going to be using the MIT license, which you can read more at spdx.org. Next, we're going to create our contract. We're going to name this chatting app, just like our file name. Instead of constructor, we're going to start with a struct for each message that we are going to send. Now, a struct is like a group of information, sort of like a record. In this case, we want to create a new record every time a new message is sent. And within each message record, we want to record the address of the sender, the address of the recipient, the timestamp saved as a number, and the content saved as a string. And we're going to create an array of messages, map them to an address, and we're going to do this twice, one as sent messages and another as received messages. Then we're going to create a very simple but very important function called send message. And this will take in the address of the person receiving this message, a string, which is the message content, which will be stored in memory. And this function will be public. Now, each time the send message function is called, we want to create a new message record where we will save message.sender, the person calling the function as sender, the recipient as the recipient, the current block timestamp as the timestamp, and finally, a message as the content. What we're actually doing here is creating a new instance of the message and recording all of the data that we wanted to record earlier according to the details being entered within this function. Now we are going to update the send messages mapping associated with the function caller and push the newly created new message there. And then we're going to update the received messages associated with the receiver and also push the new message there. Pretty simple, right? Next, we're going to create two getter functions which do not write any data to the blockchain, only read them. So we're going to call the first one get sent messages. This one will be public, view only, and will return a message array. And it will simply return all sent messages that were sent by the function caller. We will also create a new function called get received messages with the same modifiers, and will also return a message array. This one will only return received messages also associated with the function caller. Now, this is the entirety of our smart contract. Pretty basic, right? As earlier mentioned, we won't be going into any advanced features or functions for this tutorial. We just want to show What are the things needed in order to allow users to send messages as data and receive them if they were sent to the user's wallet address? If you have any ideas for more advanced features, you are free to go ahead and play around with this code. For now, we're pretty happy with this. We are going to go ahead and compile and deploy this smart contract. We are now going to compile and deploy our smart contract. To compile it, let's open up our terminal and run npx hardhat compile. There we go. As you can see, we have compiled one Solidity file successfully. We are now ready to deploy our contract to Sepolia network. To do that, let's go over to the deploy.js file within our scripts folder. Now you can see here some default code that is associated with the earlier test contract they gave us called lock. But since we have deleted that contract file, this one will actually not work and we will need to enter our own code. I'm going to remove these helpful comments over here. I'm going to remove these two lines since we won't be needing them. This one as well. In the deploy.js file, we can actually find some default code already. Now this one was written specifically for the lock.sol file that we saw earlier and deleted. So this code will actually not work for us. We're going to be writing something very similar, but to keep things easier for us and to avoid any errors, I'm going to delete everything and write our deploy.js code from scratch. So we're going to need to require hardhat in this file and an async function called main. I'm going to create a variable called chatting contract, which will await hre.ethers.getContractFactory and the name of our contract, which is chatting bout. Then I will create another variable called deployed chatting contract, which will await the chatting contract to be deployed. Then we will actually wait for that last one to be successfully deployed. And then we're going to want to see it in our console log, deployed to deployed chatting contract dot address. Now this will print for us the actual contract address of the contract once it is live on the blockchain. And then outside of the main contract, we are going to try to catch any errors. Now we need to set up a few things before we can actually deploy. I'm going to install the .env library in order to create some private environment variables. In this case, I will want to store my RPC URL, my private key, and my API key privately. This will be stored in a .env file over here, and I will be adding these three variables. Now, I will not be showing the actual contents of these variables as it defeats the purpose of storing them privately. Now, I've made a mistake over here. Make sure that the .env file is actually within the hardhat folder with the rest of our files and folders. Going back to our hardhat.config.js file, we are going to enter the network that we want to use for this deployment. So right under the Solidity line, we are going to write network, and within a curly brace, we are going to write Sepolia. Now, before we can fill in the information over here, we will be needing those environment variables that we stored in our .env file. So at the top, we are going to add another require line, which is require.env.config. Now, within the Sepolia section, we're going to write URL process.env.rpc URL. This is actually the variable name that we stored within our .env file, and it contains the URL or RPC of the network we're using. And after the URL, we are then going to write down process.env.private key, which is yet another environment variable. This one being the private key of our wallet. Now, after the networks line, we're going to want to add etherscan and insert the API key, again coming from our .env file. This one will store, this one actually holds the API key of our etherscan account. Now we can save our hardhat.config file. Now that that's all ready, I'm going to open up my terminal again. I'm going to run npx hardhat run scripts/deploy.js-network and Sepolia. Now the terminal has returned me an error. It says no matching function, argument key, value deployed. And the error seems to be occurring in our deploy.js file. So let's take a look at that. Now, if we take a look at the hard hat documentation, it is actually suggesting a slightly different code for our deploy.js file. Let's try to adapt this instead. Now, if we take a look at the hard hat documentation, it is actually suggesting slightly different code from what we've seen previously. So we're going to try to adapt this for our deploy.js code. Now, instead of get contract factory, this should be deploy contract. We're going to remove this line, change this into chatting contract. Now, instead of get contract factory, this should be deploy contract. Let's remove this line, rename a deployed chatting contract to just chatting contract. And instead of deployed, this should be wait for deployment. And instead of address, we're going to change this to get address. Let's save this and try it out. We are once again going to run npx hardhat run script /deploy.js /network sepolia. And let's see if it works this time. And instead of just .address, we are going to change this to await chatting contract .get address. Let's see if it will work this time. And there we go. We can see now that it successfully logged in our console, deployed to, and it returned our contract address. Now we can use this to search for our contract on the block explorer. Now we're looking at the Sepolia Ether scan, and we can see our transaction is actually live. We have a transaction hash, a block number, and the age, which was 55 seconds ago. We can also see my wallet address, which is the address I used to deploy this contract. Before we can actually do anything with our contract on Etherscan, we will have to verify the contract source code. We can do that by going back to our VS Code. Now, to verify our smart contract, we will need to run the command npx hardhat verify --network sepolia, and then the address of our recently deployed contract. Now, in order to verify our smart contract, we will need to run the command npx hardhat verify --network sepolia and our recently deployed contract address. There we go. As you can see, we have successfully submitted the source code for our contract address, and we can see that it has been successfully verified on Etherscan. You can actually follow this link right here, and it will take us right to our contract code. And here we go. We can actually see that this is the contract that we wrote earlier. This is visible to anyone who has our contract address and knows how to look it up on Sepolia's Etherscan. If we scroll up a little bit, we can actually read the contract or write to the contract. Now, I am going to be connecting my MetaMask wallet right here. I'm going to connect both of my accounts since I will be using these two addresses to send a message and view the messages from the other side. Let's try sending a message. Now, I'm currently connected with my account 1, so I will be sending a message to my second account. And I'm going to type a message string called, "Hey, me. This is also me." Now, MetaMask is popping up because it will actually ask me to confirm this transaction and pay the appropriate gas fees. Now, you might be wondering, it's strange to have to pay something each and every time you want to send a message. Now, this is another one of those features that can actually be fixed with something called gasless transactions, but we won't be going over that today. Let's view our transaction right here. There we go. There we go. Just like we saw earlier, we can click to show more, and if we scroll down, we can view the input as UTF-8, and this is what we're seeing. Now, since the process we took is a little different from sending it directly using MetaMask, the input data is also a little different, but still very much readable. Let's see how it looks when we use the contract's built-in functions instead for reading received messages. Let's go back to our contract page to read contract. Now, I am instead going to connect from my second address. Now, I am instead going to connect from my second address and see if I've received the earlier message. There we go. So we can actually see the recorded data at the sender address, the receiver address, which is me, the block timestamp, and the message string. Now we know that it works. But if you wanted to take this a little further and create a more user-friendly interface for sending messages and viewing the messages you've sent or received in a more appealing way, we're going to have to create a front end for that and integrate our smart contract functions into the front end code. So we'll do that in the next step. So there we have it. We have created a very simple, very basic smart contract for sending messages from one wallet address to another over the blockchain. This occurs with no middleman, no central server whatsoever. The process is as quick and simple as that. Now, if you want to make this a bit more user-friendly or something that's more appealing for users to use as an actual decentralized application, we will need to create a front end for that and integrate our smart contract functions into that. And we'll look at that in another video. For now, I hope you learned something from this video. Thank you so much for watching, and we'll see you in the next one.